give me one event for every interrupt that you receive, and then you get all the kind of interrupts. And you remove the ones that are noisy, and then you start pressing keys or sliding the slider or doing this kind of thing, switching on and off your backlight, switching on and off your Wi-Fi, switching on and off your GPS, and you try to see what kind of GPIO pins or interrupts happen, or what happens on the device when some kind of external event happens. So you can learn more about how the device works. It supports a number of different ARM-based system on a chips, so you can do these kind of things. You can also load any of your own code and also load Linux into RAM and try to boot from that while the system is still in Windows CE. Yeah, you can use that. You find documentation on the net. I don't want to go into the details. Time is running quickly. Obviously, what you can do is disassemble the drivers. Before you can disassemble as in assembly language the drivers, you actually have to disassemble as in unpackage the Windows CE ROM files, which is a very unpleasant exercise. This is the kind of various tools and scripts I had to use for the Glowfish, which like spending a day in the hex editor and trying to figure out what they did. And then in the end, you might get the actual DLLs, or might be able to recreate the DLLs for the drivers, and then you can use IDA or any other disassembler of your choice and try to find out what's happening. These are the kind of drivers that I was looking at for the Glowfish project. By now, I think there is very little that I don't understand in that hardware. So how do you do that? Well, the DLLs are completely stripped. Windows drivers are data-driven, so you don't have many symbols or function names. So if you try to disassemble a Linux driver, it's very easy because there's lots of function names that get called that have meaningful names. But in Windows drivers, it's basically everything is read and write and I/O control. It's like, oh, well, great. And all the details happen in data structures, so it's much more difficult to take things apart. Luckily, there's API documentation on the internet, all kinds of interesting things in there. The registry of Windows CE-based devices also gives you all kinds of hints. For example, most of the drivers have some kind of registry keys, and they might indicate some operational parameters, like what kind of GPIOs they use or something like that. Yeah, and then we get to the various links to the various projects. Just have a look, check them out, and finally my thanks slide. So I suppose there will be some questions. We do have time for questions. Yeah, I could even demo some things if people were interested in particular demonstrations, but I think that we should probably rather do in the Hack Center downstairs. Recent developments like if you look at devices that are, like I indicated, let me just state that before we go into the questions. If you look at devices like the G1, the phone that, this escape button. Anyway, it was just a thanks slide. We can just leave it like that. Oh no, there is actually a way how I can skip all that. Yeah, great. If you look at the G1, the HTC phone that Google now sells, at least in the US and maybe some other places, or you look at the iPhone to some extent, but actually even more so the G1, what we see are these smartphone on a chip devices. That's a term that I just came up with. I don't know whether it's somebody else uses that in the industry, but as I said, you take the entire system and put everything in a single component, and that is sort of the danger for people who would want to work with mobile phones. I mean, as in community people who want to do whatever kind of hacks on them. Because right now, if the application processor is a standard industry processor, a standard industry system on a chip, you can get the documentation for that. So you at least get, how do the peripherals work, what instruction set does it use, how does it access its various interfaces. But with these tightly integrated system on a chip, smartphone on a chip devices, that gets increasingly harder because suddenly the top secret, super whatever, proprietary information that relates to the GSM modem that the companies believe is so secret and has to be so protected well, suddenly is extremely close to the application processor again. And therefore, any information about the application processor they fear might leak some information about their super secret GSM side, and then their entire business model would collapse for whatever reason that nobody else knows. So I see sort of, like, we can do this now with current devices, with devices of the last couple of years, but looking for the next couple of, like, 5 years, I think it will be really hard. Also because things like cryptographically signed images for booting, and yes, they can be cracked and so on and so on, we all know that, but it's getting harder and harder every year to do hacking on phones. So I'm very pessimistic, and now I'll take questions. Thanks.
Yeah, I've got actually two questions. The one is, you stated very clearly that in smartphones we have the baseband processor and we have the application processor. But in terms of protocol, I mean the mobile phone protocols are quite good documented, and I don't see a really good reason why they should be separated. The DSP with the modulation, okay, that should be a separate processor, but couldn't be the functionality of the baseband processor and the application processor be merged to save one part, which would save battery power?
The battery power, I think, is not that much of an issue, because you have a certain CPU load, and if you put that on a single CPU, just the load on that CPU increases. Now, what you pay, well, so there are parts of the industry who want to move that, and I can assure you that all the major manufacturers of cell phone chipsets have that solution in their drawer right now, but they're not really happy to put it out of their drawer. So what they do is basically use a hypervisor and virtualize, and you have different virtual domains for the baseband and the other side. The reason why they want to keep it separate, I think, is one of them is there are, I think, like 4 GSM stacks that have been written. So those 4 companies who license these in millions of units every year, they make tons of money of the fact that they have a GSM stack. And if you, how can I say, the more open you are with regard to putting it on a general purpose processor that is documented where people run applications on, people will be able to reverse engineer faster or to find out, and will probably replicate what you have done, and thereby your profit margin might go down. You might not sell as many stacks anymore, you might not get as much royalties, and so on and so on. The other thing is always, oh, the operators, are afraid of their network stability and so on. But as you said, the protocols are open. Somebody who wants to build open hardware and wants to talk these protocols can do it, and it's definitely not a problem to do. The reason why they want to do it, the handset manufacturers, is to save ARM core license royalties. It's not the battery power, but like every ARM core in these devices, and for example, the OpenMoko phones have 5 ARM cores, right? Wi-Fi has an ARM7, GPS has an ARM7, Bluetooth has an ARM7, baseband has an ARM7, and the application processor has an ARM9. And for each of these cores, there are patent and whatever royalties to be paid to ARM. And if you can reduce that number, you can save, $1 per license or whatnot, and that obviously is a big commercial aspect.
And another question, or maybe a statement, you said that the GPS module is connected to the baseband processor on some phones. Couldn't that be due to the fact that you want the GPS module be constantly active? Because on my OpenMoko I have the problem, if the thing goes into standby and I re-enable it, it takes 40 seconds for to get a fix, and then it goes in standby again.
No. That's unrelated. The power, like how do you power, so the power hierarchy in devices is typically very different from the data hierarchy. So you can very well have a device connected to your application processor, but keep it powered up while the application processor is shut down. There's no problem with that. That's a pure software and hardware design choice, basically. I don't actually know what.
Just one question.
Okay, one more question from the left side this time. Jake.
Hi. Thanks. Nice pants. I'm curious what you think about things like Android, and if we'll ever see a cell phone where we'll have something other than the GSM bridge. So it's kind of 2 questions. Instead of the AT bridge, we'll actually have access to the raw GSM stack.
I don't think in the industry this will happen, right? So if the community doesn't come up with something like that, it won't happen. In the last couple of years, there's been a lot of community projects that do research on one or the other part of GSM. I've been involved in a number of those, and the fundamental problem is that there is a really big lack of skills. Like the GSM protocol side, there are not that many people on the planet who really understand it, and those people all work for companies that don't allow them to talk about it or to work on something else that's not related to their company. Getting used to how all this works is, well, I think it's an interesting intellectual challenge. The initial GSM specification, when it was published, I think in the early 90s, was already 4,000 pages. I don't know how many pages this is by now. The pages are the specs are very well defined. You can read them, you can understand them, it's possible. If you're interested, try to do that. And there's nothing that prevents you from implementing a fully software-defined radio-based GSM or 3G handset on something like the USRP with GNU Radio or some other hardware. So it's just, people have to be interested in that, get involved, have to actually do some work on this. There's nothing that, like, especially for 3G. So 2G, the GSM side, still has the proprietary crypto, which has leaked. But in the 3G world, even the ciphers and everything are publicly documented. So every single bit of the entire protocol is documented. You can all write that in free software. There's nothing well, there's patents and so on, which, yeah. But at least technically, there's no reason why you could not implement everything in software and have complete access to all the bits on the lowest level. Okay, well, thanks again.